Good day, everyone. I am Baymer Bianca Escayanga, and I am with Richelle B. Tique. We are from 3BSCE Main-1, and we're going to discuss our topic for today, which is about symbols. At the end of the topic, you would be able to identify electrical diagram and symbols and interpret plan using electrical symbol. Symbols are a shorthand way of showing the locations, types, and sizes or ratings of electrical wiring and equipment, and the interrelationships between these items. It should be emphasized that drawings need to be supplemented with specifications in order to establish the details of the electrical systems. So symbols or mga simbolo in Filipino are a quick way to show the locations, types, sizes, or ratings of electrical wiring and equipment, as well as their interrelationships. It should be emphasized that in order to establish the details of the electrical systems, drawings must be supplemented with specifications. An electrical schematic diagram or circuit diagram is a drawing that shows the connections and components in an electrical circuit. It makes it easier to understand how to build a particular circuit. We use symbols for the components in circuit diagrams because it's quicker and requires less artistic skill. An electrical schematic diagram, or also known as circuit diagram, is a drawing that depicts the connections and components of an electrical circuit. So it says here that a schematic diagram makes it easier to understand how to construct a specific circuit. We use symbols for circuit diagram components because it is faster and requires less artistic skill. So it means using symbols for circuit diagrams helps a lot because it takes longer to finish what we're doing if we don't use symbols. Let's proceed to the next slide. There are different types of electrical drawing and diagrams. These are pictorial diagram, block diagram, schematic circuit diagram, single line diagram or one line diagram, wiring diagram, ladder diagram or line diagram, logic diagram, riser diagram, and electrical floor plan. Pictorial diagram. The simplest of all diagrams is the pictorial diagram. It shows a picture or sketch of the various components of a specific system and the wiring between these components. This simplified diagram provides the means to readily identify the components of a system, even if you are not familiar with their physical appearance. This type of diagram shows the various components without regard to their physical allocation, how the wiring is marked, or how the wiring is routed. It does, however, show you the sequence in which the components are connected. So it says here that the pictorial diagram is the most simple of all diagrams. It depicts a picture or a sketch of the various components of a specific system, as well as the wiring that connects these components. These simplified diagrams allows you to quickly identify system components even if you are unfamiliar with their physical appearance. This figure is an example of pictorial diagram of an automobile starting and ignition system. Next is block diagram. A block diagram is a type of electrical drawing that represents the principal components of a complex system in the form of blocks interconnected by lines that represent their relation. It is the simplest form of electrical drawing as it only highlights the function of each component and provides the flow of process in the system. Block diagrams are easier to design and is the first stage in designing a complex circuit for any project. It lacks the information about the wiring and placement of individual components. It only represents the main components of the system and ignores any small components. This is why electricians do not rely on block diagram. So, a block diagram is a type of electrical drawing that depicts the main components of a complex system as blocks connected by lines that show their relationship. It is the most basic type of electrical drawing because it only highlights the function of each component and provides the system's process flow. It says here that block diagrams are easier to design and is the first stage in designing a complex circuit for any project. It is deficient in information on wiring and component placement. It only represents the system's main components and ignores any small components. So that's the reason why electricians do not rely on block diagram. Next is schematic circuit diagram. The schematic diagram of an electrical circuit shows the complete electrical connections between components using their symbols and lines. Unlike wiring diagram, it does not specify the real location of the components. The line between the components does not represent real distance between them. It says here that the schematic diagram of an electrical circuit depicts the complete electrical connections between components using symbols and lines. It does not specify the actual location of the components, and the line connecting them does not represent the actual distance between them. Single line diagram or one line diagram. Single line diagram or SLD or one line diagram is the representation of an electrical circuit using a single line. As the name suggests, a single line is used to denote the multiple power lines such as in three-phase system. Single line diagram does not show the electrical connections of the component, but it may show the size and ratings of the components being used. It simplifies complex three-phase power circuits by showing all the electrical components and their interconnection. They are used for determining and isolating any faulty equipment in any power system during troubleshooting. The SLD uses dedicated electrical symbols and icons for different components. It says here that a single line is used to represent an electrical circuit in a single line diagram. As the name implies, multiple power lines, such as those found in a three-phase system, are referred to as a single line. It also says here that a single line diagram might show the size and ratings of the components being used but not their electrical connections. They are used to identify and isolate any defective equipment in any power system during troubleshooting. The SLD uses specific electrical icons and symbols for various components. Wiring diagram. The wiring diagram is used for the representation of electrical components in their approximate physical location using their specific symbols and their interconnections using lines. Vertical and horizontal lines are used to represent wires, and each line represents a single wire that connects between electrical components. So, wiring diagram is a visual representation of the physical location of electrical components. Wires are represented by vertical and horizontal lines, and each line represents a single wire that connects between electrical components. So in this figure, The vertical and horizontal lines that we see are wires.
Ladder diagram or line diagram. Ladder diagram are electrical diagrams that represent an electrical circuits in industries to document control logic systems. It resembles a ladder, which is why it is named ladder diagram. There are two vertical lines. The left vertical line represents power rail or voltage source, while the right vertical line represents the ground or neutral. Each horizontal row represents a parallel circuit called rung. They are called ladder diagrams because they resemble a ladder, with two vertical rails and as many rungs as there are control circuits to represent. For example, if we wanted to draw a simple ladder diagram of a lamp that is controlled by a hand switch, it would look like this in the picture. Simple ladder diagram of a lamp that is controlled by hand switch. L1 is the hot conductor, and L2 is the grounded or neutral conductor. These names are purely for clarity's sake and have nothing to do with the inductors. The actual generator or transformer powering the circuit is deleted to make things simpler. The actual transformer or generator delivering power to this circuit can be seen in the picture. The operating voltage for the switch contacts and relay coils in the industrial relay logic circuits will typically, though not always, be 120 voltage AC. Sometimes, ladder diagrams are used to build and record lower voltage AC or alternating current and even DC systems. Logic diagram. Logic diagram represents a logic circuit by showing complex circuit and process using various blocks or symbols. The logic functions are represented by their logic symbols, whereas the blocks are used to represent complex logic circuit. These blocks are labeled with their logic function for better understanding without knowing the internal structure. Logic diagrams are used to represent the start, stop, execution of a circuit. The diagram should also be able to represent the various timing devices found in the actual circuit. There are mainly three types of timers. A type 1 time delay device delays the output for a specified amount of time, but stops the output when the input signal is removed. Type 2 time delay device and type 3 time delay device, when an input signal is received, you are a time delay device of the first kind. Type 2 time delay device and type 3 time delay device when an input signal is received. A type 1 one-time delay device delays the output for a specified amount of time, but stops the output when the input signal is removed. Riser diagram. The riser diagram is the illustration of the physical layout of electrical distribution in a multi-level building using a single line. It shows the size of conduits, wire size, circuit breaker rating, and other electrical devices such as rating of switches, plugs, and outlets, from the point of entry up to the small circuit branches on each level. It shows the layout with the alarm system as well as telecom and internet cables. Electrical floor plan. It is a vertical representation of various appliances such as lights, switch, and fans in a building. It specifies their exact location with their size and distance from each wall and ceiling. It shows a scaled version of each room from above. It usually contains legend that provides a visual explanation of the symbol used in it. Electrical floor plan are sometimes called electrical drawings or schematics. It is a type of technical drawing that provides a visual representation and describes circuits and electrical systems. It consists of electrical symbols and lines that show the engineer's electrical design to the customer. In other words, the electrical plan shows the location of all electrical equipment. An electrical drawing can include all of these important details described below. Connecting electrical wiring to the other parts of the system, connecting various components and installations to the system, transmission lines with details such as size, voltage, power rating, and capacity, power transformer, and its winding connections, and main switch, tiebreaker, and fuse switch. Electricity plan benefits are: plan highlights all potential risks to make changes quickly before significant damage is done. It helps keep your system running safely, efficiently, and smoothly. Electricity planning saves time by avoiding delays and problems. The design specifies everything to avoid dangerous situations. As a result, it helps professionals complete their work on time. It also saves money because no one wants to spend more than they already have. The draft contains all the details such as wire lengths, cable types, and other parts needed to complete the project, so you don't have to spend a lot of money on unnecessary things. An electrical plan can help prevent injuries by showing all areas of the building that could pose a hazard to the technician. Components of a basic electrical circuit. Every circuit is comprised of 5 basic components. Number 1. A conductive path such as wire or printed etches on a circuit board. 2. A source of electrical power such as battery or household wall outlet. And number 3. A load that needs electrical power to operate such as lamp. 4. Control device switch is a switch that controls the flow of current in a circuit. Switches can be activated manually, mechanically, or automatically. Number 5. Overcurrent protection device or OCPD is a disconnect switch with circuit breakers or fuses added to provide overcurrent protection for the switch circuit. A fuse in an overcurrent protection device with a fusible link that melts and opens the circuit when an overload condition or a circuit occurs. A circuit breaker is an overcurrent protection device with a mechanism that may manually or automatically open the circuit when an overload condition or short circuit occurs. Electrical symbols and electronic symbols are those symbols that are used for drawing schematic diagrams. Here, we provide these electrical symbols in the form of a table where you get each and every symbol with their family. For the next slide, I will show you the different kinds of electrical symbols. We have the general outlets, which are lightning outlet, blank outlet, drop cord, fan outlet, junction box, lamp holder with a pull switch, clock outlet, fluorescent fixtures, and floodlight. Next, we have convenience outlets, which are the duplex receptacle, single triplex receptacle, 3-conductor split duplex receptacle, 3-conductor split switch duplex receptacle, weatherproof receptacle, range receptacle, switch and receptacle, and special purpose outlet undesignated. Next, telephone. We have interconnecting telephone, outside telephone, switch symbols, single pole switch, double pole switch, 3-way switch, 4-way switch, automatic door switch, switch and plot lamp. Next, auxiliary symbols. We have electric door opener, push button, buzzer, bell, annunciator, smoke detector, and innermost. Lastly, we have miscellaneous, lightning panel, power panel, branch circuit in ceiling or wall, branch circuit in floor, exposed branch circuit, home run to panel board. We also have the symbol battery, connection, connected, no connection, multitester, voltmeter, ohmmeter, ammeter, the motor, pump, connector, the round type, connector, the flat type, eyelet terminal, ignition switch, which is circuit symbol, ignition switch, wiring symbol, switch, 2-terminal, switch, 3-terminal type, switch, combination type, relay, normally open type, relay, normally closed type, light bulb, ground, 3-phase alternator, single-phase alternator, pulse generator, ignition coil, the single type, ignition coil, the dual type, spark plug, resistor, variable resistor, coil, solenoid, LED, and the capacitor. Slide is standardized wiring diagram symbols. As we can see in this picture, we will see the battery symbol. The symbol for a battery is shown below. A large and a small line is supposed to represent one battery cell, so that the image below would suggest a 2-cell battery of 3 volts. But usually, people just draw the battery symbol with 1 or 2 cells no matter what voltage it is. Capacitor symbol. Capacitors are either polarized or not. The symbols that are commonly used for the two are shown below. Polarized capacitor is marked with a plus sign. It is important to distinguish between these two because the polarized capacitor needs to be placed correctly according to the plus sign. Resistor. The schematic symbol of the resistor are drawn into two different ways. The American style resistor is drawn as a zigzag resistor, while the European style resistor is drawn as a rectangular resistor. Transformer symbol. The symbol of the transformer looks like two conductors with something in between them. That's because that's basically what a transformer is. Switch symbol. A switch can be represented in numerous ways in a circuit diagram. Crystal symbol. The crystal is a component used to create a stable clock frequency, often for microcontrollers. In circuit diagrams, it looks like or have the trim caps, inverting amplifier, and proper output buffer. The crystal is not as multi-featured as the oscillator. So that's all for our report. Thank you for listening. This is Rachel Tique with Bea Marie, Bianca Kayanga,